Good morning. Today I am going to explain the topic minimum cost is parity. Minimum cost is parity means for a given graph G there exists a subgraph G dash. It contains all the vertices of G and it contains n minus 1 edges such that it should not form a cycle. So if the graph has 4 vertices, it contains all 4 vertices and it contains only 4 minus 1 edges. So here you can see the given graph with the 4 vertices and you can generate the spanning trees. These are all different spanning trees. So here the spanning tree cost is nothing but cost of edges. Here the cost of edges is 7, which is at 6. So this is 10. So here the cost of the spanning tree minimum. So you see here the spanning tree with the minimum cost is called minimum spanning tree. The spanning tree with minimum cost is called minimum spanning tree. For a given graph G, there can be more than one spanning tree. If weights are assigned to the edges of graph, then the spanning tree which has the minimum cost is called minimum spanning tree. So there are two types of algorithm to generate the minimum cost spanning trees. One is Prim's algorithm, second one is Kruskal algorithm. Prim's algorithm, Kruskal algorithm. So this Prim's algorithm start with a node which is having the minimum cost edge. So here these are the vertices 1 to 6. Here we have to generate a spanning tree with 6 vertices and 5 edges. So here if you have to draw a cost efficiency matrix, when you draw the cost efficiency matrix, you can find the edge 1 to 2 is 10. You can see here edge 1 to 2 is minimum. So you select the 1 to 2 10. So here you have to find the edge which is minimum. So here we can see 1 to 2. 1 is connected with 4, 5 and 2. 2 is connected with 6, 5, 3. Among these you have to find the minimum. So here Prim's algorithm follows the adjacency. Prim's algorithm follows the adjacency. You can see the explanation. Select an edge with minimum cost and include the spanning tree. So here 1, 2 is the minimum cost. We include it to the spanning tree. Here the spanning tree is represented in the form of a matrix which is having the n minus 1 rows. So you have a 6 vertices. So you will get the 5 edges. So here 5 each edge is stored in a row. So first row contains first edge 1, 2. So first column contains the starting vertex, second column contains the ending vertex. So here 1, 2 is added. Next 1, 2. Connecting with 1 or connecting with 2, what is the minimum cost edge you have to identify? Connecting with 1 and 2, you identify 2 to 6.5 is the minimum. So you add this one. Now 1 to 6 is in the spanning tree. 1 to 6 is the spanning tree. So you have to identify the vertex among 3, 4, 5, which is forming the minimum cost edge. So here 1 to 6 is in the spanning tree. Non-spanning tree versus 3, 4, 5. You identify 3 is the minimum. So 3 to 6 is 15. So we have to add that 5 edges. You can see here if any edge is forming the cycle, you should remove. So you see here 1 to 4. 1 to 4 is 30. But 1 to 4 forms the cycle. Already 1 to 1 to 2, 2 to 6 is in the loop. If 6 to 4 forms 1 to 6, 4 forms a cycle. So that kind of edges you have to remove. For that you have a Prim's algorithm. You see here Prim's algorithm. Select an edge with minimum cost, including the spanning tree. So when you added edge, 2 vertices were added to the spanning tree. Then these vertices are forming the edges with non-spanning tree vertices. Among those all the edges which are adjacent to the selected edge. So here selected with spanning tree vertices and all the vertices which are not in the spanning tree. Identify the edges with the minimum cost. So you have to identify edge with the minimum cost. So Then that minimum cost edge we have to add to the spanning tree. This we have to repeat until n minus 1 edges have be included. So at each cell you have to see it should not form a cycle. For that you have an algorithm called Prim's algorithm. So Prim's algorithm, first what is the input? Graph is given and the cost adjacency matrix. N versus no n by n adjacency matrix is given. So if there is an edge, the cost of edge is represented. If there is no edge, infinity. So output is minimal spanning tree. Minimal spanning tree is nothing but it is in the form of a tree. How to mention the edges? So here n minus 1, n vertices means n minus 1 rows, and we have a number of columns, 2 columns. Column 1 for to store the starting vertex of edge. Column 2 is to store the starting vertex of a ending vertex of a edge. So here, suppose from the minimum, from the given cost matrix, we have to identify the vertex which is edge, which is having the minimum cost. Here 1, 2 is the minimum cost edge. Add to the spanning tree. You can see here spanning tree first row. 1 means first row. First row, first vertex is 1. First row, second vertex is 2. So here from the cost adjacency matrix, minimum 1, 10. Minimum cost is now 10. Only one edge is added. 10 is added. Now here you have to update the near. So 1, 2 is in the spanning tree. Remaining vertices are not in the spanning tree. So you have to update near. So K and L is added to the spanning tree. You see here, what is K? 1 and 2 is added to the spanning tree. So near of 1 is 0, near of 2 is 0. So remaining vertices you have to update. So you see here, for I equal to 1 to L, if each vertex, whether it is equal to 1, whether it is near to 1, whether it is near to K, you have to update. Other than 1 and 2. 1 and 2 already in the, any vertex, if it is added in the spanning tree, it's near, you make it as a 0. So here, near of I equal to 1 or near of I equal to 2. You have to update like that. So here, 1 near, what are the vertices are there? 4 is there, 5 is there. 2 near, what are the vertices are there? 6, 5, 3. We'll see here. So near of 1 already in the spanning tree, 0, near of 2 already in the spanning tree. So near of 3 to the 3 which is near, 2 is near with the weight 50. To the 4 which is near, 1 is near, weight 30. To the 5 which is near, 2 is near. To the 6 which is near, 2 is. Among these you have to select a minimum cost edge. So here 6 is non-spanning tree vertex is forming a edge with the spanning tree vertex. So here 6 and 2 is the edge you have to select and its weight is 25. So earlier 10 you have 10 plus 25, 35 now. Now 1, 2 and 6 is added. So 1, 2 and 6 is added. So remaining 3, 4, 5 is there. Earlier near of vertices wide updated with either 1 or 2. Now 6 is added. One more vertex is added. So if any vertex among these vertices forming the less cost edge, you have to update. So 3 is near to 6, 15. Earlier 3 is near to 2, it is 50, but 3 is near to 250, but now 3 is near to 6. So update with this. So you have to update like this. 4 also near to 6. So you updated. What is the minimum cost? 3 to 6. So now near of 3, make it 0. Now update 4 and 5 such that what is the near? So here already 4 is forming with 6. Recently added 4, 3. 4 to 3, no edge. So no need to update. But 5 to 2 is 4 now. 5 to 2 is 40. But now 3 earlier added now. Now 5 to 3 is 35. Update this one. So 5 to 3. Now what is the minimum? 4 to 6. So select the minimum cost edge. Now again update. Now 4 is added. Now make near of 4 0. Now only 5 is there. 5 is forming. You check which it is near. Is 5 to 1 is 45, 5 to 2 like that you have to check. It should not form the cycle. What are the vertex you are adding? Now 5 to 3 is 34. So all these vertices were added. All cost edge. Earlier 10 is there. Now 10 plus 25. 15 plus 20 plus 35. You get the minimum cost spanning tree. See, this is the spanning tree and its edges you have to sum up 10, 25, 15, 35, 20. This is the minimum cost spanning tree. So you have to identify the vertices with the minimum cost spanning tree. So this is about the spanning tree algorithm. Just read and trace this algorithm once or twice, then you can understand.